Hi, Assalamualaikum warahmatullahi wabarakatuh. So we are from Group 1 and today we will learn together about Chapter 5, Integrals under subtopic Integration of Functions. So firstly, we will introduce ourselves first. My name is Atila Nurmanisha binti Jalaluddin and my matrix number is D20241110514.
And my name is Muhammad Azim bin Azmi, matric number D202411105116.
My name is Muhammad Aiman Zikri bin Adnan. My metric number D202411105339.
And my name is Nurhat Fina binti Fizal and my metric number D2024111053. And our lecturer name Dr. Nur Azan Aini binti Mat.
Now, we go to the learning objective. At the end of this lesson, student will be able to determine the indefinite integral of exponential function and natural logarithmic function. Student will also can evaluate definite integral involving exponential and logarithmic function by applying appropriate integration rule and limits. Now, we will explore the integration of the exponential function of the e to the power of x. What makes this function special? This function has a special property where its derivative is the same function, which is d over dx of e to the power of x equal to e to the power of x. Since the integration is the reverse process of differentiation, the integral of ex is also ex. For example, the integration of ex dx equal to ex plus c. The constant c represents the constant of integration. Now, we will go to the example of indefinite integration. For the first step on how to solve this question of indefinite integration is you must copy the function of e to the power of x as the answer. Step 2, add the constant of integration. Now we go to the first example, which is the integration of negative 23 over 5 e to the power of x dx. For the first step, just copy the original function, and at the end of the answer, you must add the constant c. For the second example, in the integration of 10 multiplied by e to the power of x dx, first you must copy the original function, and then at the end of the function, at the end of the answer, you must add the constant c. Are you understand right now?
Yes.
Okay. Now we go to the definite integration of the exponential function for that rule. For the first step, you must copy the integrand and write its antiderivative. For the second step, write the antiderivative with limits. And for the third step, substitute the upper limit b. For the fourth step, you must substitute the lower limit a. And for the last step, you must subtract the value between upper limit and lower limit. Now we go to the example, which is the integration of 3 over 4 ex dx from 1 to 2. First, you must copy the original function, and then write the antiderivative with the limit 2 and 1, and then substitute the upper limit and lower limit into the original function, and then this we got the final answer. Do you have any question?
Yes, I have a question. How about integrate 5 e power of x dx?
Okay, now I will show the answer to the whiteboard. What is the question?
Integrate 5 e power of x.
Okay, integrate 5
e
e
power
of
of
x dx. So for the first step, you must copy the original function, and then for the second step, you must add
constant c.
Yeah. So that's all from me. Thank you.
Okay, Assalamualaikum. Hi, my name is Fina. You can call me Miss Fina. Today, I want to teach you about integration of the exponential function. Basically, we had two types of integral for the exponential function, which is definite integral and then indefinite integral. So let's move to general form for integrating an exponential function. Integrate e power of ax dx equals to 1 over a e power of ax plus c. So let's move to how to solve the question like this. For the first step, we need to look at the exponent of e and we identify the number multiplying, which is A and we divide by that number, but we keep exponential part the same. And don't forget to add constant C at the end. So let's move to example 1, indefinite integral. The question given is integrate e power of 3x dx. So here the value of A is 3. We just need to substitute into the general form, or we can divide by the value of A and then we keep the exponential part the same and just put the constant C. You can choose either one type of calculation. Don't forget to look at the power first, divide by A. No constant C, answer is not complete. So let's move to example 2, which is definite integral. So the question given is integrate e power of negative 7x dx from 0 to 2. So the value of A is negative 7. Basically, we just need to divide with 7 and then we substitute the value of the limit. And then we get the answer. Don't need to put any constant C because it has limit integrating is specific. So we get the value answer. So for the notes, look at the power first, divide by it. Don't forget to substitute the value in the equation. Any question?
I have a question. My question is integration 10 e power of negative 5x dx. How to solve it?
Okay, I will show to the whiteboard. Can you repeat the question?
Integration 10 e power of negative 5x dx. Negative 5x.
So the first step, you need to define the value of A, which is negative 5. And then we need to divide with the back to the equation. And then we just simplify the answer. And don't forget to put constant C.
Assalamualaikum and good morning everyone. My name is Muhammad Azim. You can call me Sir Azim. Okay, in previous lesson we already know about how to integrate the exponential function. So today we want to learn about integration of the logarithmic function. Okay, in calculus it is important to know how to integrate the inverse function of x, which is fx equal to x power of negative 1. We can integrate this function by following this formula. Integration of 1 over x dx is equal to ln x plus c. In this equation, the absolute value of ln x is very important because in logarithm, the power inside the absolute value will always be positive. So, are you guys understand?
Yes.
Okay, let's move to the first example of the indefinite integration. For the first example, the question is integration of 1 over x plus 3 dx. We can just use the general form of the formula and get the answer, which is equal to ln x plus 3 plus c. In the indefinite integration, we must always put constant at the end of the answer. So, for the second example is integration of 3 over x dx. If the numerator is bigger than 1, we can bring the numerator forward. So, it will be 3 integration of 1 over x dx. Then the function, we just integrate it as usual. Become 3 ln x plus c. Okay, let's move to the definite integration. For the first example, the question is integration of 1 over x plus 3 dx from 0 to 2. We can integrate the function become ln x plus 3 from 0 to 2. We must always remember to put absolute value in ln value. So it will become ln 2 plus 3. Before that, we must substitute the value of x. And then it equal to ln 2 plus 3 minus ln 0 plus 3. And the final answer, we can simplify it by using logarithm rules. Equal to ln 5 over 3. Okay, you guys get it?
Yes.
Okay, for the second example, we use a negative value of x. So the question is integration of 1 over x dx from negative 5 to negative 2. As usual, we integrate the function first. So it will become ln x from negative 5 to negative 2. Then we will substitute the value of x. Ln equal ln negative 2 minus ln negative 5. If the absolute value, what we need to do? we will positive the number inside the absolute value. It will become ln 2 minus ln 5, and then we will simplify the answer, ln 2 over 5. If you guys notice, in definite integration, we doesn't need to put constancy because the limit of integration is already specific. So then we must remember to always put the absolute value in the equation. Okay. So, any question?
Can you show how to solve this question?
What equation?
The question asks to integrate to integrate 1 over 5 minus x dx.
Okay. So the question is integration of 1 over 5 minus x dx. So by following the general formula is 1 over x dx. So we must positive the value of x here. We can factorize the value, come like this, 1 over minus x minus 5 dx. We can bring forward the negative part outside the integration and become 1 over x minus 5 dx. Then the function, we can integrate it as usual, minus ln absolute x over 5 plus c. In this equation, we must always remember to put absolute value and constancy. Okay? Are you guys understand?
Yes.
Okay. That's all from today.
Hi, Assalamualaikum everyone. My name is Atila. So you can call me Miss Atila. So in the previous lesson, Sir Azim already told you about the first form of integration of logarithmic function. So I will show you the second form of integration of logarithmic function, which is integration of f prime x over fx dx. Okay. Do you know how to solve if the question show this kind of form?
No.
No. Okay, so I will teach you step by step. Okay, so the first step is we should understand what the question looks like. Look at the fraction carefully, which is which is the integration of f prime x over fx dx. So as we can see, the denominator fx is the function and the numerator f prime x is the derivative of that function, right? Okay. So the second step is we should recall an important fact about logarithms. We must remember this formula, which is d over dx ln fx equal to f prime x fx. So when we differentiate ln fx, we will get f prime x over fx. Okay. So the last step is reverse differentiation. Okay. So since d over dx ln fx is equal to f prime x over x, then we will get the integration of f prime x fx dx is equal to ln fx plus c. Don't forget to put c at the end of the answer. Okay. Let's move to the example. The first example is the indefinite integration. So the question asks to integrate 2x over x squared dx. Okay. You still remember the first step, right? Okay. We have to look at the fraction carefully first. Okay. This is like I showed before. So we compare 2x over x squared. So what you can see from the questions?
The denominator is function and the numerator is the derivative of the function.
Yes, correct. Okay. The second step, we have to apply the formula. As I said before that we should remember this formula. So we just substitute the value of fx and the value of f prime x over fx, which is fx is x squared and f prime x over fx is 2x over x squared. So when we differentiate x squared, we will get 2x. Okay. So the third step, since d over dx ln x squared is equal to 2x over x squared, then the answer we will get the integration of 2x over x squared dx equal to ln x squared plus c. Okay, the second example is definite integration, which is we have the limits for the question. So the question asks to integrate the integrate 2x over x square plus 1 dx from 1 to 2. Okay, step 1. Look at the fraction carefully. Okay, so can you tell me about this?
The denominator is the function and the numerator is the derivative of the function.
Okay. Okay, correct. So, the second step, like I said, we have to apply the formula. Just substitute the value of fx and f prime x over fx, and when we differentiate x squared plus 1, we will get 2x. Okay. Step 3, since d over dx ln x squared plus 1 equal to 2x over x squared plus 1, then we will get the answer the integration of 2x over x squared plus 1 dx is equal to ln x squared plus 1 plus c. Okay, for this question, we have extra step, which is we have to apply the limits. Okay, we where upper limit minus lower limit, and we substitute the value of x, which is this one is the value of upper limit and the value of lower limit, and then we just simplify and we'll get the answer. So basically, the answer of this question is ln 5 over 2. So that's all from me. Thank you. So based on what we learned today, this following reference were referred to gather information on this topic. So that's all from us. Thank you.
Bye.